Hello and welcome to another episode of How Bad Can You Budget? And today we are doing another EICR and well, the smoke alarms have got problems to start with. I am not sure what to expect with this one, so I'm going to give you a little tour and then we're going to get stuck in and start testing out, but I've got a feeling there's going to be a few hidden disasters in here. It looks a little bit rough. So as always, hit the thumbs up if you like my videos, subscribe. I know that 63.2% of you watch my videos and don't subscribe. Not acceptable. Hit the subscribe button, hit the notification bell, and let's get into it. So as we walk in, we've got a light switch here, does the lights. Now there is a cupboard here. So I'm guessing consumer unit is going to be here, and yes it is. You know I love these ones. My favourite brand of consumer unit. Good old British General. So 6 circuits, not too bad, so hopefully it's not going to take too long, this one. And as is classic with the old BG consumer unit, the lid is impossible to fit properly, so the main switch is kind of just chucked in behind the lid. Same with these. This is, there we go. I mean, this is a classic thing with the BG consumer units, unfortunately, is that the lids are rubbish to fit. Blank is kind of half missing, so that's a little bit dodgy. So that's going to need to be sorted out properly. We've got a cooker circuit, 32 amp, socket circuit, 32, lights, 6. That one I presume is a spare, but we'll see when we get the cover off. Central heating, 6 amp. Lights, ground floor, 6 amp. Kitchen sockets, 32 amps, so fairly standard setup. We've got type A, C RCDs, no surge protection device, so let me know in the comments, would you code or not code the lack of a surge protection device? I'll leave you to argue amongst yourselves in the comments about that. Underneath, this looks fairly neat, so one nice thing, okay, let's take our hats off to whoever installed this. They didn't just bung the cables in through a hole in the bottom of the board. They did put a whisker gland in, so that's really nice. And we've got 3 earthing conductors going into the board. It looks like 116mm, which is probably our main earthing conductor here. No way. Oh my goodness, I literally did not set that up. Oh, that's crazy. Okay, well anyway, that's needs tightening up. Let's see, these ones are okay, but that one's just never been tightened up, which is a bit dodgy. So we've got, basically this is a 16mm off the sheath of the supply cable. So it's a TNS system and a clamp, a normal BS clamp for the earth off the sheath, which I know many of you will say needs to be reported to the DNO, as it should be a sweated connection. I'm not sure about that, to be honest. And there's this bonding conductor which goes into a bit of trunking here. So we'll have a look where that goes. But then we've got what seems to be 2 main bonding conductors here as well, going down and through the skirting here. And they've just drilled a lovely little hole through the skirting, clipped up. Could be better, could be worse. So let's follow this one bonding conductor, and it goes along in this trunking here, and it pops down here. And it's a solid floor. So I don't know where that goes, but let's look for our main, here we go, okay. So it looks like it probably comes out, goes under the stairs, and goes to this, which is some kind of old steel water pipe or something. It's painted in. It does have a label, not the best, but just about acceptable. So I'm guessing that's like an old water or gas pipe. Not sure about that. Let me know in the comments if you know what that might have been. So presumably then our bonding for our other services is outside. So let me take a look at that. Okay, yeah. So we've got gas. Gas here going into the meter. So I'll get the meter box open. Where's my meter box cable? There we go. So yeah, we do have a main bond and it looks to have been done fairly well. But we'll do the old jiggle test just to be sure, and that seems to be fairly solid, so that's good. Again, another broken meter box. I'm yet to find one that's not broken. I think they need to redesign these because they're literally all broken. And this gate is kind of this gate's kind of blocked, so I'm going to have to go around the other way. I'm going to have to go around the side here to find where that goes to. But it probably goes along and back through the wall here to the under the sink, I should imagine. Yeah, they've clipped it all the way along here, all the way round and through there. So presumably we've got our main stopcock for the water under here somewhere. And yeah, there it is. So they've cut a little flap out of the box there, and that looks fairly decent as well. So looks like we might be dealing with a half-competent electrician who's actually installed this, which is a nice change. So let's have a little tour around the property. So this is the kitchen, and we've got a socket here by the door, of course, because that's really the most practical place for it. Then we've got another socket here with a couple of switch fuse connection units, presumably for appliances under here. So that's a freezer, nice and mouldy. Very mouldy. Yeah, so we've got two sockets under there, both on their own switch fuse connection units. So I'm going to unplug that in advance. That's a little bit loose, so it could do with tightening up. But that's looking fairly decent so far. Then we've got a socket here for the kettle or something, and an isolation switch here, which presumably is for the cooker. Gas hob with a spark, so I presume that's plugged in somewhere as well. Can't see any kind of, oh yeah, here we go. Under the units, of course. So we've got two plugs here. Presumably then one for the cooker, one for the oven, yeah, and one for the hob. And they've just basically come off the back of the switch for the cooker into this double socket in 6mm cable, and then they've put both appliances on plugs. Let me know what you would do about the fact that this socket is just loose underneath this cupboard. It kind of doesn't really bother me that much, to be honest, because it is accessible for maintenance if you want, because you can take the plinth off. The only thing is if there was a flood, obviously it's quite low down, but it's not really doing any harm there, to be honest. So I don't think I would really code that, but let me know your thoughts in the comments. Then the rest of the property, we've got these metal light fittings, so you're going to have to check if those are actually earthed or not. Double socket there, not many sockets, single socket there, as is usual with these rental properties. There's a single socket here and an old loose double socket, not sure what that's doing there. Bit of trunking under here, and then another single socket under here. There is this old, it looks like a back boiler, gas, and then there's some kind of isolation switch for it there, so we're going to have to check that. A little flex going through that hole there next to the pipes, not great. Another metal light fitting, switches, everything's surface mounted here, so presumably they've done a rewire at some point. The smoke alarms are, oh wow, okay, the smoke alarms are bleeping, I'm not sure why. Maybe they're out of date. 2026, strange. Okay, that does work. So I'm not sure why they're bleeping. Yes, so toilet, very old school, separate toilet to the bathroom. And okay, we've got an electric shower, so that is obviously that 40 amp circuit which is not labelled. So we do have that to think about. Looks like they've run it in trunking, possibly run through the back of this switch box and up into the loft. No isolator switch for the shower as far as I can see. No pull switch and no manual switch. Okay, and this is a classic. So this is when alarm bells start to ring, is when you see a pendant that close to the window, because that indicates that this property has not been rewired since it was built. Otherwise they would probably have, I can't do that, I can't reach. And they would probably have moved them to the centre. So I'm going to take that off. It's likely that they've changed that for a more modern pendant recently, but that the wiring is actually existing. Because if they rewired it, I would have thought they'd have moved it to the middle. And we've got a little bit of a funny socket going on here. Why is it upside down? These are quite entertaining, these properties, to be honest. I do get a bit of a kick out of going around these places because they're just so hilarious, some of them. Oh look, here we go. Shower isolator. How nice. So the shower appears to have been wired in 1mm twin and earth, or at least that's the cable that goes into it. It comes, okay, maybe it's not a shower that heats up the water, maybe it's just a pump, so I'll check that. It looks like there's two twin and earths, 2.5 twin and earths coming in, so that might be on the ring, and then it goes out in 1mm. Hopefully that is the case, but I'll have to check the shower for that. Central heating programmer with a nice little junction box here with a bit of cable loose, so that's not great. Not great at all, really. And CPC's been cut off there as well, if you can see that. See that little dot there? That's the CPC. So that is some kind of, oh, it's rubber. It's VIR, look at that. VIR stands for vulcanized Indian rubber. And basically we're not allowed to use that cable anymore. It's past its usable life. So that is an instant rewire when you see that stuff. And that is going down, okay, so that's going down to this plug. I think it's just a loft light probably. Because this is on a plug and then it goes up into that junction box and the VIR cable goes up and through into the loft. So I'll have to check up in the loft what's going on with that. This is obviously socket for something and a switch fuse connection unit for, goodness knows, maybe the central heating system. Obviously you've got various bits and pieces here. This is the wiring centre, so presumably that's powering the central heating system. There is no immersion heater, it's just been capped off. There is a bit of supplementary bonding here, so that is probably from the pre-RCD days. Not the best, but it looks functional. Pump for the central heating, motorised valve, an old vintage socket, look at that, an old vintage MK socket on a wooden back plate. That is a blast from the past. Bakelite, these things are made of. So that's obviously from the original days when this place was first wired up. It looks like it's not in service anymore, but we'll have to check that. And here, again, we have a pendant by the window. We've got a socket which looks like they've probably rewired this place in surface trunking. Only two single sockets in this fairly large master bedroom, which is not great. And then in here, we've got a single socket, which is obviously back to back with that other room. And then we've got another single socket down here. Cupboard with nothing in it. So going to jump up in the loft. Wow, it looks like it's fairly well insulated up there. So I'm going to jump up there, stick my mask on, and just see what I can find up there with that VIR cable and anything else that's going on. And then that, yeah, it looks like there's some kind of loft light system going on. Then once I've looked up there, then I can start doing some tests. So, welcome to the loft from hell on a day like this, as it's really hot. Okay, so we've got a switch here. So there is a couple of loft lights. It's quite a big loft actually. Pretty impressive. So they've wired it in what seems to be 2.5, or maybe it's the 3-core, I don't know, but it's quite a thick cable going up to that first light, and then it looks like just a normal 1mm twin in earth going across to the other light. But what I'm interested in more than anything is where that rubber cable comes up, because it comes up just in the corner of this cupboard here. I kind of wanted to see if it was in use or not, but it doesn't appear that it is, because I did leave that socket switched off, so presumably that's not in use anymore. But what on earth they had it trailing up here for, I have no idea. But I am not going to stay in this loft for very long because it is very, very hot. Very, very hot indeed. I don't know why they've left the loft hatch open. It's a bit weird, really. Right, so a bit of further investigation. I found that rubber cable. It goes out through the wall there. So I assume it's doing a security light on the outside or something. I'll have a look, but probably it can just be disconnected. Right, so I've just popped my head out the window here just to see if I can see that cable popping out of the loft, but I can't. There is an aerial there, but obviously that's an aerial cable, not a power cable. But if I drop down here, I see this conduit going across to the shed, and that concerns me slightly because I have a feeling that probably the whole thing has been wired in that VIR cable of that plug top. So I'm going to have to check out in the shed to see if there is any wiring in there and if it's in VIR or not. Right, well there appears to be a mysterious set of keys on the side here. I'm wondering if they are for the shed. So this is that conduit I was telling you about. A nice little bend. I reckon somebody's been doing pull-ups on it or something. Yeah, and here's the shed. So let's see if this key works. Yeah, it does. It's a good start. Okay. Wow, this place is like a coal bunker or something. Crazy. But here's our VIR. Check that out. Wow. So, yes. Vulcanized Indian rubber. These old Bakelite. Oh, nice. A bit loose there. Old Bakelite switch and socket arrangement, and a baton holder, and this is our VIR cable that comes in through our steel, well, I don't know if it's even steel to be honest. The conduit there comes through there, clipped along. These are the old-fashioned clips, by the way. They're quite nice, these. I mean, they do comply with the regulations again now. We could start using these again, and I think these look nicer than any metal clips that they put out these days. Certainly nicer than the standard metal twin and earth clips that they have produced, but to be honest, these take forever to install, I think, so that's the downside on them. But they are just like a strap, basically, like that, and then that folds over like that, you see? So they nail on, there's a nail under there, and then you basically fold it over, slide, it's like a belt, you slide it over like that, and then you slide it back over itself, and that is as solid as anything. I don't make things like they used to, love. So anyway, this VIR is, well, it's quite a beautiful thing to see, to be honest, but it's clearly not allowed anymore, certainly not in a rental property like this. I mean, I could insulation test it and it might test out okay, but realistically it's beyond its usable life and needs to be ripped out. But for the moment we can just disconnect it, just cut the plug off that cupboard thing. I mean, that's dodgy anyway, that's not earthed or whatever. But we can cut the plug off in the cupboard and just make it safe so that they can't use this, basically. Well, the keys are there, so the tenants will have access to the shed, so it's definitely not good to leave it connected. Interesting though, eh? Right, well, we're already like 20 minutes into the video, and as you can see, we've only just started testing. And that gives you an idea how long an EICR should take. I mean, I've already been here over half an hour just literally doing visual inspection on the place. It's funny because I had a tenant reply to one of our messages today, because we send a standard message to the tenants to try and book in these EICRs, and we always say it takes 3 to 4 hours, depending on the size of the property. Obviously, some of them it takes longer, but for, say, a standard property like this, 3-bed, semi or whatever, 3 to 4 hours. The power will need to be turned off for quite a lot of that time, and we will be maintaining social distancing, wearing masks, blah, blah, blah. So we got a reply saying, I don't understand why on earth would it take 3 to 4 hours? Surely it should only take half an hour. So we sent them one of my YouTube videos, which I did as a little advert, electrical installation condition reports in Cambridge. It's about a 4-minute video, but I use it as a kind of an informational video, basically to tell clients what an EICR actually involves. So when I'm quoting for EICRs, I just send them that video and say, this explains our EICR process. And it's quite a good sales technique, actually, because you kind of just use the video to do your salesman pitch for you. So it works quite well. But it explains that, it takes about half a day and all the circuits need to be thoroughly tested. We will do this test, that test, the other test. We will remove a certain amount of accessories for visual inspection, blah, blah, blah. People don't realise, I think they think you're just going to come in and do a bit like the gas safety thing. The gas safety inspection probably only takes about half an hour, doesn't it? But it's not the same as an EICR. I mean, EICR is seriously thorough. So anyway, where was I? Here we are, consumer unit. So I'm going to just turn the main switch off to make it as safe as possible. Sorry, let's do that again. First of all, I'm going to turn off all the individual circuit breakers. If you're an apprentice watching, this is what you're supposed to do. Turn off the RCDs, then turn off the main switch. You shouldn't turn this off when it's fully loaded, ideally, because it could arc or something. That's the kind of theory behind it. In this case, the house is empty anyway. There's no loads connected whatsoever. So I'm not really worried about that, but just trying to show good working procedure and all that. So I'm going to take the cover off. Obviously, the reason I've turned everything off is just to minimise the amount of live parts within the consumer unit when I take the lid off, because you never know how they've done it. So can you guess, is it going to be a good BG consumer unit or a bad one? I think it's going to be fairly good because of the way that they've done it, but we'll see. Okay, yeah. I mean, I've seen a lot worse, but it still just screams, I don't really care. I mean, it's just spaghetti really, isn't it? Such a shame. It doesn't take any longer to do a consumer unit neatly than it does to just sling the wires in like that. So I don't get it really. Such a shame. But anyway, we've got a 10mm for the cooker. It's quite hefty. We've got a ring circuit here. We've got a 1mm for the lighting. Ring circuit in 2.5. That was a spare. So that shower upstairs is just a thermostatically controlled shower. It's got hot and cold water pipes to it. So it's not heating the water, it's literally just a little pump in it. So that spur for it in the cupboard is absolutely fine. Another RCD, and we've got this one, which is the central heating, and then we've got another lighting circuit and another ring circuit. So this should be fairly straightforward, easy to access everything. I'm going to start by doing my continuity checks on the bonding conductors. I'm going to take them out of both ends, something that people gave me a little heads up about. You should technically disconnect them here and at the bonding clamp, so you're literally just measuring the conductor rather than the pipes and stuff like that, apparently. I used to just take them out at this end. I don't really understand why you should take them out both ends actually anyway, because if you take it out at this end, you're measuring, you can only possibly be measuring from that end of the conductor to the other end of the conductor. There's no way that you can get any kind of back feeds from the pipe or anything. So I think that's a load of rubbish, whoever told me that. But anyway, we need to tighten this up. So actually, while it's loose, we might as well just disconnect the main earth here and do a ZE test. It's one of the first things when you're recording the details of the incomer. So we've got a 60 amp main fuse, we record all the cable sizes, etc. This is quite classic. We've got 25mm tails from the meter to the consumer unit, but only 16mm from the cutout to the meter. And it is one of those old meters, but it is 80 amp rated rather than 40 amp, which is one of the ones I did the other day that I showed you a video of. That was 40 amp rated, so that was a little bit more dodgy. This one's 80 amp rated and the main fuse is 60, so not the end of the world, but I mean, they could probably do with a smart meter really. So I'm going to do ZE, then I'm going to do continuity on my main bonding conductors, then I'm just going to go around and do a long wander lead test anyway, all the metallic points in the house, just to check if there's any kind of lack of continuity of CPCs anywhere. And then I'll do my R1 and R2 tests at my furthest points. Then I'll do my RCD tests. I'm not doing live testing anymore apart from on the sockets because I'm just trying to avoid working on anything live as much as possible. So I'm only doing plug-in tests live because that's safe to do, which in this case I can only do it on the 2 ring circuits basically. I can't do it on any of the other circuits. But we can do R1 and R2 and then add that to the ZE to get a calculated figure for ZS, earth loop impedance. And that's perfectly acceptable to do that. I know some people will disagree with me on that. And what we will try and do is the double leg test on the rings. I failed miserably doing it the other day, so we'll give that another go again here and see if I can demonstrate that for you. Just to show you a close-up here, because I kind of realised that the camera was quite zoomed out on that last shot, so you couldn't really see. This is the consumer unit. See what I mean? Let me know your thoughts in the comments. It's just not been done with pride. It's not been done badly as such, like, you know, there's not loads of connector blocks in the back or anything, but it's just not been done neatly, which is such a shame. As you know, I am obsessively concerned with neatness as well as doing a proper job. I think doing a neat job shows pride in your work, and that's really important. So I've got my main earthing conductor disconnected there, and so what I'll do is do an earth loop impedance test from that to the line conductor in the consumer unit coming into the main switch. That will give me a ZE figure, external earth fault loop impedance, and also then I'll do a PFC test once I've reconnected that, because you should do PFC tests with all the earthing conductors connected. I'll do that from PSC, which is between live and neutral, and PFC, which is between live and earth. And then I'll do my continuity on my bonding conductors. My tester got wet the other day and it stinks now. The strap, this strap is made of like wetsuit material, and basically the strap is still kind of damp and it just smells like it's gone a little bit mouldy. And I have been offered a Metrel multifunction tester by someone for a very good price, but I can't really afford it at the moment. Unfortunately, it's still for the Matrel MFT and the EV charging adapter, you know, usually it'd be about 1,600 quid or something. I've been offered it for 1,200. But when I've got perfectly functioning, oops, I'll stop talking and start working properly. When I've got a perfectly functioning multifunction tester at the moment, I just can't really warrant splashing out at the moment. But I am tempted. So, ZE, earth clamp on the main earthing conductor, which is just the one that comes from the sheath of the cable. So we're not connecting, we're not measuring any other earthing conductors or bonding conductors. And then we go on the incoming live conductor to the board, and we've got 0.44. So it's a TNS system. So let me know in the comments for you apprentices, what is the maximum allowable ZE for a TNS system? 0.44 is acceptable, by the way. It's within the limits. So type away, and in a few minutes I'll tell you the acceptable reading. So we're going to reconnect these bonding conductors now down here. So we'll reconnect these earthing conductors. Now this terminal, this main earth terminal, should be labelled. It should have a label saying main earth or safety earth connection, do not remove, something like that. So that is something that should be improved on. It's a C3, requires improvement because it doesn't comply with the current regulations, but isn't necessarily unsafe. So that's fine, that's all reconnected. So now we'll do our PFC test, which is carried out from the main earth terminal to the line tail, and we've got 0.43, which is very similar. And this is the reading that we want, so PEFC, prospective earth fault current, in other words, the maximum fault current that can flow to earth in the event of a direct short between line and earth is 563 amps, or 0.56 kilo amps Ka. And then we do the same test from line to neutral. Now you can do it using your pointy things, or a little tip that I usually do is just turn the main switch on, and then I just do it between, with my crocodile clip, I'll just do it like that. That's an easier way of doing it, but you know, it doesn't really make much difference. 0.35, and we've got 691 amps, or 0.69 Ka for fault current, which is, that is our highest reading, so that's the one that we'll record on the EICR form. So now that we've done that, we will disconnect our bonding conductors, which are here, and we will do a R2 test, an earth continuity test, CPC continuity test rather, from here to the gas bond, and from here to the water bond, and also from here to that old pipe that was bonded as well.